Hello, Algebra 1. Today we're going to be looking at, wait, there's the problem of the day. Hold on a second. Today we're going to be looking at section 4.4, part A, arithmetic or arithmetic sequences. Well, listen, I got to be honest with you. These are, I've often been kind of frustrated by these because it's really just basic math. All it is a list of numbers. Whenever you're talking about a sequence, they're just talking about a list of numbers. And the list is usually created by some kind of operation. So either you're adding, subtracting, multiplying, dividing, each successive number. But it's just a list of numbers. And but it turns out an arithmetic sequence is very specific. It's adding and subtracting. So once you have this list of numbers, you can graph it, you can write an equation, you can do all sorts of things. But at its most basic, it's just a list of numbers is what a sequence is. Okay, so a sequence is an ordered list of numbers. Each number is called a term. So so 5 is the first term, 10 is the second term, the third term. Each term, and then they note it often with a sub n, has a specific position. So like I was saying, the first term is 5, the second term is 10, the third term is 15. Okay, so in an arithmetic sequence, I already talked about this a little bit, but it's addition and subtraction. The difference between each pair of consecutive terms is the same. This difference is called the common difference. So that's some pretty important vocabulary right there. Each term is found by adding the common difference to the previous term. Okay, so you got this arithmetic sequence here. If you want to know what the common difference is, take the newer term and subtract from it the previous one. So 10 minus 5 gets you 5. That's your common difference, is 5. And to get each successive number in the sequence, you're going to add 5 indefinitely to get the rest of them. All right, so on this one, it would be 13 minus 15. I could have done 11 minus 13. Either one's fine. But I get negative 2. And with a common difference of negative 2, that means I'm adding negative 2 each time, or I'm subtracting 2 each time. All right, so here we've got a sequence, and the spacing's a little weird here, I apologize, but it says write the next 3 terms of the arithmetic sequence. So it's usually helpful to figure out what the common difference is. So negative 14 minus a negative 7, well, you're going to add the opposite. You're going to get negative 7. They are adding negative 7 each time. So the next one would be negative 35. Then negative 42, and then negative 49 would be the next 3 numbers in the arithmetic sequence. All right. You can also graph these things. And what they like to do is they like to make the position the x value, and the term value would be like the y value. Okay, so the a sub n is the actual term value at position n. So they describe it as plotting n, a sub n, where n is the position, a sub n is the term at that position. Okay, so to graph this, you're going to be thinking first, second, third, fourth. So our n values are the up top to here, our a sub n values are over here, and they ask us what we notice. Okay, so I think we are good just going by ones here. I don't think I need to change my interval. So at my first term, I go up 4, make a dot. So yeah, we're just going by ones here. For my second term, the second position, I'm at 8. My third term, I'm at 12. And then at my fourth position, I'm at 16. And it says, what do you notice? Well, what I'm noticing is it was very consistent. We were adding 4 each time, and what that does was that was actually a slope. That was a slope. This is linear. Yeah. So it turns out arithmetic sequences are linear. They're going to be linear. If you're adding the same thing each time or subtracting the same thing each time, when you graph it, it's going to be a line, which is pretty cool. All right. So here, for example 3, they say, does the graph represent an arithmetic sequence? Well, I'm noticing it looks, I think I can take a straight edge. I think I can take a straight edge and line those up perfectly. So we're in good shape. Yeah, because this is linear, yeah, it's going to be an arithmetic sequence. Yep. And if you're like, well, I'm not so sure, maybe, just maybe it could be linear and not be an arithmetic sequence. And I do kind of get that idea here because, well, yeah, I could see how you could have a list of numbers and it might skip, where it needs to be. And the dot may turn up, over here, and it would still be on the line, So maybe we should go beyond just being linear. Maybe we should double check and just see what the common difference is. And it looks like they're subtracting 3 each time, and that holds up. So we are, in fact, an arithmetic sequence on that graph there. All right. Well, to make things even more enjoyable, we can write an equation for sequences, which is actually pretty cool, I guess. But I will tell you guys, I'm always going to give you this formula. It's always been given to me. I've never had to memorize it, so I'm not gonna make you memorize it. But this formula is kind of interesting because basically you want to think of like an as like your y value and n is like your x value. You're not going to plug in values for those, right away. To write your equation, you're going to leave those alone, but you are going to fill in for a1, which is the first term, and for d, which is the common difference. Okay, the common difference. So you're going to fill those in, and then once you do that, you've got an equation, which is pretty nice. Because once you've got the equation, you can predict values in your sequence that wouldn't be easily found otherwise, if that kind of makes sense. So like, we're going to find the 50th term. We're going to find out the 50th term after we write our equation. Getting the 50th term would not be an easy endeavor, and if you're like me, you'd kind of lose track of what position you're really at. And yeah, so we're going to use our equation. But first we got to write the equation. To write the equation, like I was saying, you leave an alone, but you fill in the first term. The first term's 14. Leave the n alone. And then your common difference here, 11 minus 14, is -3. I'm going to do parentheses -3 because I don't want it to look like I'm subtracting. And that's it. You've got an equation. That's an equation for it. Some people like to distribute it and basically simplify all this. It puts it into more of like a slope-intercept form, and some people like to do that. And I get that. That can save you some time when you find out the next part, because the next part is find out what the 50th term is. So how I want you to write this is I want you to write A50 equals, but then you're going to use your equation. You're going to put 50 in for n. And what I would recommend you do is grab a calculator, and you can do order of operations is what I would do. 50 minus 1 is 49. And then your calculator, 49 times 3 negative equals -147. And then finally add the 14. And yeah, the 50th term is negative 133. And again, that would have been difficult to do without the equation. All right, so this one, same deal. A sub n equals 1 plus n minus 1, and then multiply by the common difference. So 0 minus 1 is negative 1. We're going to multiply by the common difference of negative 1 is what they're doing each time. And so that's your equation. You could clean it up if you want, but then we want to find the 50th term. And again, I'd grab a calculator. 50 minus 1 is 49 times, oh, actually I don't need a calculator because 49 minus the negative 1 is negative 49. Negative 49 plus 1 is negative 48. So the 50th term is negative 48. All right, and again, I want to emphasize, I'm always going to give you this formula. You won't have to memorize that formula. All right, and then here's an application problem talking about buying purses. The bids have to go up in $5 increments, and so when you list it out, it's an arithmetic sequence. The minimum bid was 60. That's where it started. So it says write a function that represents this sequence. So I can do that pretty good. Looks like my common difference is going to be 5. My first term is 60. So yeah, I'm ready to write my equation. A sub n equals 60 plus n minus 1 times 5. Bam, got it. They want us to graph it as well. So, so see how our data doesn't start until we get to 60? Something you can do is I can't remember what this is called, but do a little squiggly, which means we're going to skip over some data till we get to the data that's important. So we'll start at 60 right here, and we'll just go by 5s. Make this real easy on us. Okay, and over here we'll just go by 1, 2, 3, 4. All right, so 160, make a dot, 265, 370, 475, and yeah, that's we graphed it, yay. And then this is where it's kind of interesting. They're actually asking us some interesting questions right here. It says the winning bid is $105. How many bids were there? That's an interesting question. Okay, so we're going to use our equation up here. But 105 is not the position. It's not the bid number. 105 is the bid amount. It's the actual term value. So to use this equation, we want to know when the bid was, what the bid number was to get 105. So we're going to put 105 out here. And then we are going to solve an equation. And some people would recommend distributing the 5. You totally could do that. I'm going to be a weirdo. I'm going to just grab my calculator and do this all on my calculator. I'm going to undo things. I'm going to subtract the 60 over. 105 minus 60 is 45. So 45 equals n minus 1 times 5. And then I'm going to do 2 more things. I'm going to divide by 5 to get rid of the 5. And then I'm going to add 1 to get rid of the 1. And I get that the 10th bid is what will be our answer there. So yeah, there you have it. Have a good day. See ya.